Welcome back. In this video we will discuss how to find a domain of a function. So we will take the problems from Stewart Calculus 6th edition, problem from the section 1.1. Okay, let's start with problem number 27. We have the following function: f of x is equal to x over 3x minus 1. Okay, the domain is the set of all x such that the function makes sense, or all possible inputs such that the output makes sense. So for example, if we give an input 1 to this function, we have f of 1 is equal to 1 over, so let's see, f of 1 is 1 over 3 times 1 minus 1, which is 1 over 2. So whenever we give an input 1, we get 1/2. Okay, it means that 1 is belong to the domain of f. Why? Because whenever we give an input 1 to this function, we get an output 1/2. So the domain of a function is the set of all inputs such that the output makes sense. Okay, so let's see here. So instead of trying to find all possible inputs such that the output makes sense, we can also try to find for which input the output does not make any sense. As we can see here, it is a fraction, and the only possible way that this fraction doesn't make sense is whenever the denominator is equal to 0. Okay, so f of x does not make sense when 3x minus 1 equal to 0. So let's see, 3x minus 1 equal to 0. Actually, we don't want 3x minus 1 equal to 0, but we want to pinpoint for which x this is happen. So 3x equals 1, therefore x is 1/3. So it says, this computation says that the only way f of x doesn't make sense is when x equal 1/3. So therefore the domain of f is the set of all numbers x such that x is not equal to 1/3. So all numbers except 1/3. If you want to write the domain by using the interval notation, then here we have a number line and 1/3. So we have the whole number line except 1/3. So we exclude that 1/3. Therefore the domain in the interval notation is from -infinity to 1/3, and then union from 1/3 up to infinity. Okay, let us see the next problem. Problem number 28. We have g of x equals 5x plus 4 divided by x squared plus 3x plus 2. By the same reasoning as before, the only way g of x does not make sense is whenever the denominator equals 0. So let us try to find out for which x the denominator equals 0. So the denominator equal to 0. We want to find x such that this equation holds true. So basically we want to solve this equation. Okay, this is a quadratic equation. You can use factorization if it is possible, quadratic formula, or completing the square to find the solution to this equation. So let's see here. In this case, we can factor the left hand side into x plus 1 times x plus 2. equals 0. So the only way this expression equal to 0 is when x equals -1 or when x equals -2. This computation tells us that the denominator is equal to 0 if and only if x equal -1 or x equal -2. Therefore, this function makes sense for all x except for x equal -1 and x equals -2. So the domain of G is the set of all number x such that x is not equal to -1 and x is not equal to -2. Okay, and in the interval notation, so we exclude -1 and -2, so -2 first and then -1, so we exclude that 2 point. So this domain can be written as from -infinity to -2 union from -2 to -1 and then union from -1 to infinity. Okay, now let us do one more problem. Problem number 30. We have the following function, square root of u plus square root of 4 minus u. Let's see first. What is square root of -2? Okay. By definition, square root of negative number doesn't make sense. So in order a square root makes sense, we need the input, the number under the square root, to be 0 or bigger. So the input for a square root function need to be non-negative. Okay. So in order this whole expression makes sense, first we need this number to be non-negative, and at the same time we also need that number to be non-negative. Because remember that square root of negative number doesn't make sense, so we require this number to be either 0 or bigger. So we can solve this inequality. So 4 is greater equal to u. So let us see here. So u is greater than 0, and at the same time u is less or equal to 4. So the u that satisfies these two conditions lies between 0 and 4, including 0 and 4 itself. Therefore, the domain of H is the interval from 0 to 4. Okay, I hope you will get a better understanding after you see this video. See you later on the next video.